All right, so today we're going to review solving one-step inequalities, and then we're going to talk about two-step inequalities. So we're just going to have a review. So if we were looking at this inequality symbol, all numbers, or x, is blank than 0. We'll notice that the smaller side is towards x, so that means that is our less than. So then our next one, x is less than or equal to. Remember, whenever we have that line underneath, that shows us it's like the equal sign. It's almost kind of like half an equal. Well, then over here, notice we have it flipped, that inequality symbol. So now all numbers are greater than or equal to, since we have the line underneath. And then last but not least, all numbers that are greater than. So remember, if the smaller side is first, we would read it as a less than. If the bigger side is first, we'd read it as a greater than, and then you just have to check to see if it has the equal to. Okay, so now we have our symbols out of the way. Now we need to talk about our number lines. So remember, whenever we graph, we either have an open or a closed circle. So we have one or the other. So you got a 50-50 chance. Let's see if you remember. If we look at this first one, can x actually equal 0? No, because it has to be less than 0. It cannot equal 0. So whenever we have strictly just a less than, it's going to be open. It's going to have an open circle. So what that means is it's going to be open. It kind of looks like an O. We don't fill it in. So that means if we have all numbers greater than 0, x cannot actually equal 0, so this one is also open. Then that leaves us with our equal to. Well, x can equal 0 in this case, so that's why it is closed, and we are going to fill it in. Same thing here. X can be greater than or equal to 0, so because of the equal to, it's going to be closed. So the main thing, you just want to look at your inequality symbols. If there's that line underneath for the equal to, that means it is closed. So on these two here, I'm going to have a filled in circle. And then on the last ones, they're going to be open because they do not have the equal to portion. Now we just need to figure out our shading. So all numbers less than 0. Well, what are numbers that are less than 0? -1, -2, -3, and so on. So that means we are going to shade to the left. Our next one, x is less than or equal to 0, so all numbers less than or equal to 0. Well, on this one, that would still include -1, -2, and -3, so we would still shade to the left. Our next one, all numbers greater than or equal to 0. So what numbers are greater than? 1, 2, 3. So everything going to the right. So we shade to the right. And then our last one, all numbers greater than 0. So once again, to the right. And then we just have that open circle since it cannot actually equal 0. Okay. So now let's talk about actually solving one and two-step inequalities. Step number 1, we're going to solve an inequality by using the same process, blank operations, which is our inverse operations, as when we were solving an equation. So you guys actually already know how to do this because you already know how to solve a two-step equation. So it's the same exact thing, except that we have an inequality symbol that takes the place of the equal sign. So we're going to see those different symbols instead of the equal. However, there is one caveat, and I want you to star, bubble, highlight, do something so step number 2 stands out. This is the one way that it is different from equations. So please, please, please star, highlight. You don't want to forget this. When we multiply or divide, when we multiply or divide both sides of the inequality by a negative number. Whenever we multiply or divide by a negative number, we must do something very special. What we are going to do is reverse the inequality symbol. But why? So let's just think about the example. Do you agree that 4 is greater than -2? All right, 4 is to the right on the number line, so it is bigger, so 4 is greater than -2. Well, remember when we solve equations, whatever we do to one side, we always do to the other side of the equation. Same rules apply for the inequality. So let's just say that I divide both sides by -1. Well, what is 4 divided by -1? Well, they're different signs, so that means it's -4. And then you have -2 divided by -1. Well, they're the same signs, and that means it's now a +2. Well, if I was to fill in the inequality, if I kept it the same, is -4 greater than +2? No, it's not. So what we have to do is we have to reverse the inequality so that we have a true statement. Because what just happened is if we looked at a number line, here's 0, all of the negative numbers are over here, all the positive numbers are on the right. So if we had a negative and we divide by a negative, well, it becomes a positive. So it flips sides on the number line. Same thing, if we had a positive number and we multiply or divide by a negative, it flips to be a negative. So it reverses the sides, so that's why we have to reverse or flip the inequality. So if we're thinking about this, if -x is less than 0, that means that positive x has to be greater than 0, which makes sense because the positive numbers are to the right on our number line, the negative numbers are to the left on our number line. So the opposite of a number will have the opposite relationship, which is that less than or greater than, to the final result. So it just means we're flipping sides on the number line. So anytime you multiply or divide, we must be so careful, and remember we have to reverse that inequality symbol. All right, so let's go ahead and predict. Which inequalities will require the inequality symbol to be flipped in the final solution? Well, if we're thinking about solving for letter A, well, we're isolating 3x, so the first step would be to subtract 5 on both sides. Then after that, we would divide 3 on both sides. Well, that's a positive number that we're dividing by, so that means this one will not have to flip. Let's look at letter B. The inverse operation of multiplication is division. Well, we would have to divide both sides by -2. Ding, ding, ding. We just divided by a negative, so that means we have to reverse the inequality. So letter B, we would have to flip it and reverse that inequality. Let's take a look at C. Well, we're isolating -1/2 x, so first we would subtract 9. Then, to get rid of this fraction, we have to do something special. So we would multiply by our reciprocal. Well, the reciprocal of -1/2 would be a -2/1 because we flip it. Well, if we multiply both sides by -2/1, ding, 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 we just multiply by a negative. Step number 2 up here says we have to reverse it. So that means this one would be flipped. We'd reverse the inequality. Well, let's see if we can figure out a pattern here. Let's look at the coefficient. So the coefficient of x is a +3. Well, it was a positive, so we didn't have to flip it. If we look at the coefficient over here on letter B, it was a -2. We had to flip that one. If we look at our coefficient of C, it was a -1/2. Well, we had to flip that one. So if we have a positive coefficient, we won't have to flip. If we have a negative coefficient, we do, because that means we're going to end up multiplying or dividing by a negative. So if we look at letter D, x has a positive coefficient because it's like a +1, so that means we won't need to flip it. Letter E, we have a +4, so we won't flip it. Letter F, its coefficient is a -0.5. Ding, 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 that tells us we are going to flip it. Letter G, our coefficient is a +3, so that means we won't have to flip. Letter H, well, that coefficient on x is like a -1. Ding, 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 we have a negative there for that coefficient, so that means we will indeed flip it. So let's go ahead and do an example of solving. So we are isolating just like our equations, so we isolate -2x. So that means if we're adding 10, the inverse operation would be subtracting 10 on both sides. So we are left with -2x. And then now we have to make sure we're careful. We carry that inequality. So we have -2x is greater than And then 8 minus 10 is -2. One of the common mistakes people do is that they get so used to solving equations that they accidentally put an equal sign instead of the inequality symbol. So just be careful. All right, now we are multiplying -2 and x, so the inverse operation is division. And since we're multiplying by -2, we need to divide by -2. Ding, 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 ding. We just divided by a negative, so that means we must flip or reverse the inequality. So now it becomes a less than symbol. So now we have a positive x is less than, well, -2 divided by -2 is a +1. All right, so let's come over here to graph it. So I'm just gonna put 1 in the middle of my number line, and then I'm just gonna fill it in, and I'm gonna count by ones. Remember that on a number line, you just have to be consistent whenever you're counting. Well, right here, is it gonna be open or closed? We do not have the equal to, so that means it's going to be an open circle. So at the number 1, I'm going to put an open circle. And now it is x is less than 1. So which numbers are less than 1? Well, 0 is less than 1, -1 is -2. So that means we shade to the left. Now we're going to check to see if we did it correct. So what we're going to do is we're going to choose any number in the shaded section, because that was part of our solution. We're going to choose any number and we're going to plug it into that original inequality that we started with. So let's just say x equals, we'll say -1. And you can choose any number. And now we're going to check to see if we get a true statement. Well, -2 and x are being multiplied, so that means I'm going to have -2 times -1. And then plus 10, we're checking to see, is this greater than 8? Well, -2 times -1, those are the same signs, so it becomes a +2. And then we have plus 10, checking to see, is it greater than 8? Well, 2 plus 10 is 12. 12 is indeed greater than 8, so we have a good solution, so we know we did it correct. If you got something like 6 is greater than 8, that is not a true statement, so that right there tells you that you made a mistake somewhere and that something happened.